My name is Lisbeth, and today we're going to be going over how to find the electron configuration of an element. So here we have the zinc, and we're going to do ground state zinc. That just means that it hasn't lost or gained any electrons. So that means my Z value is going to be 30. So how do I find the Z value? That's actually just the number of protons found in the element at its ground state, which is also the atomic number of it. So you just have to look at the number above the element on your periodic table. So zinc has 30 protons, and now I'm going to do the little up and down arrows, and we're just going to do the whole shebang. So first I'm going to do the arrow diagram, and then I'm going to do the normal letters and numbers, and I'm going to tell you how to find the quantum numbers, and I'm going to tell you how to find out if it's paramagnetic or diamagnetic. So we're just going to go over a bunch of stuff. Alright, so I use the periodic table to help me know, kind of as like my guideline as to which subshells I should be going through. So I read it like a book. I go from left to right. So I start at n equals 1, and I notice that there's only the 1s shell. I'm going to do my arrow diagram first. And then I see next that's going to be the 2s shell. And then I notice that there's a huge blank space, and I'm going to go to my 2p shell. And I know that's going to have 3 little subshells because it can hold up to 6 electrons. So I'm just going to go ahead and continue all the way until I reach zinc. So I did 2p, now I'm at 3s, then I have 3p, then I have 4s, and then I'm going to have 3d. I'm going to do that one on the bottom because these shells are pretty big. So that's going to be 3d. And then at the end of 3d, I notice that zinc is there, so I can stop there. Now I'm going to go ahead and fill all of these in until I reach 30, following all of my basic rules. So my rules state that I have to first I have to fill the shells with an upward facing electron. That's the Aufbau principle. And I have to fully finish filling up a shell before I can move on to the next one. That's very important in shells that are not just s, so like the p and the d orbitals. So here I have 1 up, 1 down, that makes 2. Then I have 3 and 4, and I have 5, 6, 7, 8, 9, 10. Notice how I went up, 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 and then I went back and did down, down, down. That's especially important. That's very important because that way you're not going to ruin Pauli's exclusion principle by putting an electron where it doesn't belong, and it keeps the shell happy. So you want to make sure that your shell is at least halfway full if possible. So here I have 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And that's where I end, right? So that's my 30th electron. I circled it because this little guy right here is actually going to help us find the quantum numbers. So let's go ahead and do that. So there are 4 quantum numbers. We have n, we have L, we have M sub L, and we have M sub S. Alright, so to find n, we just have to locate what period or what row the element is on. And I notice this is actually, this number right here, is going to be my n number. So 3 is going to be my n value. For your L value, if you remember, there's very specific values. So for S, L equals 0, for P, L equals 1, for D, L equals 2, and for F, L equals 3. So since it's in the D shell, that means it's going to equal 1, 2. There we go. 0, 1, 2. Usually I have to write them out, so whatever. Alright, M sub L is going to be from -2 to +2. So what I like to do is that I just kind of write them underneath it. So I have -2, -1, 0, 1, and 2. And that's corresponding to each of the little subshells, all right? So now I just have to see where my electron fell. If you notice, my last electron fell in the +2. So that means my M sub L value is +2. When I found that out, that I could just do this and find my M sub L value, my mind was blown, right? And notice that my arrow is pointing down, so that means it's going to be -1/2. So that's how I found my 4 principal quantum numbers. Now, to write it out with letters and numbers, I basically just follow the same steps. So I have 1s, and I have 2 electrons there, so 1, 2. And then I'm also going to have 2s2 because it's full. And then I look here, I have 6, so it's 2p, 6, 3s, 2, 3p, 6, 4s, 2, and then I have 3d10. That was a lot easier than just having to figure it out on the periodic table, right? I absolutely love the little arrow diagrams. They make life so much simpler. Now, let's talk about the difference between paramagnetic and diamagnetic. So, paramagnetic simply means that there are electrons that don't have a pair. So, electrons without a pair. Versus diamagnetic means that all the electrons are paired. Right? I like to think di means 2, right? The prefix means 2, so everything is in 2s. So if we look at zinc here, all of the electrons are paired up, so zinc would be considered diamagnetic. How would a paramagnetic electron configuration look like? So I'm going to do one very quickly. So I can have the 1s, 2s, and I'm going to stop at 2p. So I could have it filled up like this, and then have these 3 electrons. So here, notice that these 3 electrons are not paired up with anything. So in this species would be a paramagnetic species with 3 electrons that are by themselves. So here everything is paired up. Here we have some single ones. So this would be paramagnetic. So let's recap. So with just knowing the element, we can find out the number of electrons, right? And with the number of electrons, look at all of the stuff we can do. We can do the arrow configuration, the arrow electron configuration. We can find out the normal electron configuration. We can find out the quantum numbers, and we can find out if it's paramagnetic or diamagnetic. So that's basically like a quick, short summary of how to find your electron configurations, and I hope this was helpful.